evening. Can you hear me? Can you hear me, children? Shall we start? Okay, I'm going to start the class. Okay, how was the day? Went well? Okay, I'll start the class. Okay, I have planned 7 to 8, 1 hour. I know that you have to do a lot of homework, everything will be there. I know that. So, 1 hour will take. We'll continue that first chapter, real numbers chapter, and 1 hour, 7 to 8. Okay, may share the screen? Okay, wait. Okay, can you hear me? Okay, I'll start the class. Now listen, in the last class we have learned what is that next last class we have learned the third one, right? What are the second question? I think so. Exercise 1.2 second question we have learned, that is 510 third question, right? 336 and 54. 336 and 54. What is the question? Find the LCM and HCF of the following pairs of integers and verify that LCM and HCF is equal to product of the two numbers. This question we were doing this this 26 and 91 we have finished, right? Which one we were doing? 26 and 91 we have finished. 336 and 54 we have finished. Okay. Now I am going to take the next section, that is exercise 1.2, next one. That is exercise 1.2, the third question. What is the question? Find the LCM and HCF of the following integers by applying the prime factorization method. 12, 15 and 25. 12, 15 and 25. Okay. So, here you can see that the question is, okay. So, first question is 12, 15 and 25. What is the LCM and HCF of 12, 15 and 21? that too by the prime factorization method. Okay, so this 12, how we can find out this the LCM as well as the HCF we have to find out, right children? So this 12 we can write as what is this 12? 12 is equal to 12, otherwise we can do it together. 12, 15 and 21, 2, then 2 goes on 12 6 times. Okay, 2 will not be going, right? So common factor is 3, we will take 3, right? 3 goes on 12 4 times, 4 3s are 12, and 3 goes on 15 5 times, and 7, 3 goes on 21 7 times. Okay, so LCM and HCF, first we can write the HCF, common factor. So HCF is equal to 3, right? HCF is equal to 3. And next one, yes Arthi, yeah, good evening. Okay, I don't want to waste the time because only 1 hour I have planned, that's why I am taking this 1 hour. I want to complete this chapter, that's why. Okay, HCF is equal to 3, and what is next one? We want to find out what is the LCM. LCM is equal to, HCF is 3, common factor is 3. So 3 into 4 into 5 into 7. This is the LCM. Okay, if HCF is equal to 3, what is the LCM here? LCM, that is 5 4s are 20, 20 into 21. 20 into 21. 21 2s are 42, 420. Okay, this is the one method. That is, I think this is the easiest way. 12, 15 and 21, take the common factor 3 and do it like this. Okay, there is HCF will be the common factor. 3 is the common for all the numbers 12, 15 and 21. And now which are not common numbers 4, 5 and 7. So 3 into next one 4 into 5 into 7. Okay, this way we have to multiply. Otherwise you can do this way also children. Okay, 12 you can factorize this separately. 12, 2, 6, then 2, 3, right? So that is equal to 2 square into 3. 2 square into 3. The next one 15. Next we can take 15 separately. 15 is equal to, what is 15 is actually 5 into 3. Okay. Next one is after 15, next number is 21. 21 we can write as 7 into 3, right? 7 into 3. So what is the common factor here? 3 is the common factor, right? 3 is the common factor. So here we can write 3 is the common factor, right? 12 is equal to 2 square into 3. 15 is equal to 5 into 3. 21 is equal to 7 into 3. So HCF, here HCF common factor we can write as 3. And LCM is equal to this common factor you take. Another way I am telling. I think this is the easiest method. Always this will be the LCM and HCF means this is the shortest method. Shortest. If anyone is having any confusion, you can do this way also. LCM is equal to 3 into next one. What are the other numbers? The remaining numbers are 3 into 2 square into 5 into 7. Multiply this one. Common number is 3. HCF is 3. That 3 into 3 is multiplied with 2 square. Another number 2 square. 2 square is multiplied with 5 is multiplied with 7. That is equal to 3 into 2 square is 4 into 5 into 7 is equal to, what is 420. Okay, 420. This way also you can find out the HCF and LCM. Right children? This way also you can find out. Now I'll go to the next question. That is second question is 17, 23. That is 17, 23 and 29. All of you do it and show me the answer. 17, 23 and 29. HCF, LCM and HCF. A very easy question. 17. Second question is 17, 23 and 29. Actually, what is the common factor? 17 is a prime number, 23 is a prime number, 29 is also a prime number, right? So 17 is actually 17 into 1, right? 17 into 1. 23 is 23 we can write as 23 is also a prime number. 23 we can see in 23 table only. So 23 into 1. Okay, so 29, this is also a prime number. 29 is 29 into 1. Okay, so what is the common number, common factor here? What is the HCF? HCF is equal to common, that is 1. Okay, if there are no other common factors, we can say that 1 is a common factor. So highest common factor is equal to 1. Okay, so but here 17, 23 and 29, no other common factors are there. So we can say that HCF is equal to 1. That is the common factor is 1. Okay, common factor is 1. So what is the LCM? All of you practice with me. What is the LCM here? LCM is equal to 17 into, which are not common, 17, 23 and 29. Multiply. 17 is multiplied with the 23 is multiplied with the 29. Yes, Persia. The answer is 11339. 11339. This is the answer. Okay, HCF and LCM. So you have to understand, children, actually 17 and 23 are co-prime numbers. Okay, there is another name. If there is only 1 as the common factor, we can say that those numbers are co-prime numbers. Do you understand the meaning of co-prime numbers? 17, 23 and 29 are actually co-prime numbers. No common factors are there. Only 1 is the common factor. Okay, except 1, no other common factor. So these numbers are known as co-primes. So here 1 is the common factor. That is HCF is 1. LCM is equal to 11339. Okay, I hope all of you understood this one. Alright. So next one. Next we will take the next question is here also you can say that is 8, 9 and 25. Is there any common factor between this 8, 9 and 25? 8, 9 and 25. Is there any other common factor? 8 is in the table of 8 is in the table of 2 and 4 and 2, 4 and 8, right? 8 is an even number, 9 is an odd number, 25 is also an odd number. 9 is a multiple of 3, 25 is a multiple of 5. No common factor you can see. Am I right? So, tell me what is that 8, 9 and 23. Third question. Third question. That is the third one. Yeah, no common factor. Third question is, what is the third question here? 8, 9 and 25. Always I am telling HCF is the highest common factor. Common factor among all the numbers. Okay, if 2, 4 and 8, 2 is the HCF. Do you understand? If 4, 8 and 4, 8 and 32, what will be the HCF? 4 is the HCF. Common factor among those numbers. Okay, now here the common factor is, what is that? 8, 9 and 25. 8, 9 and 25. Now tell me, what is the LCM and HCF? 8 is equal to 2 into 2 into 2, right? That is 9. 9 is equal to 3 into 3, right? Then 25. 25 is equal to, 25 is equal to 5 into 5, right? 5 into 5. Can you see any common factor here? 8, no other. 2 multiple of 2, 9 multiple of 3, 25 multiple of 5. So no common factor. So HCF. What is HCF? HCF is equal to, what is HCF? HCF is equal to 1. Very good. HCF is equal to 1. Hi Dinanand. Hi. Good evening. HCF is equal to 1. And what is the LCM? Okay, come on, take and do with me. LCM is equal to, what is the LCM? 8 into 9 into 25. Okay, 8 into 9 into 25. That means multiply all these 2 into 2 into 2. That is 8. 8 into 9 into 25. Okay, so that is answer is equal to 1800. 1800. Okay, clear? Meaning of HCF and LCM? Yes. Now if you finish this, the next class I will be giving the repeated questions from this real numbers. Okay, I will be solving this. Well, let me finish the chapter first, then I will be giving the repeated questions. What are the repeated questions from this board questions? From this new questions are the, many new questions are there. Let me complete this first. Then I'll be taking the repeated questions. Now next one, okay, exercise 1.2, question number 3. Next question is question number 4. This type of questions are always repeating, children. This type of questions, because we are given here, what is the question here? Here given that HCF of 306 and 657 is equal to 9. So actually what is given here? HCF given. HCF of 306 and 656. Okay. HCF of 306 and 357. Right. So HCF we are given as 9. So write as 9. HCF is equal to 9. Okay. So another one we are given this two numbers we are given. One is A, another one is B. Okay. One of the numbers we are given, A is equal to 306 and B is equal to 57. So HCF given, A given, B given. Now what do you want to find out? We have to find out LCM of these two numbers. So we have a formula. Last class we have learned. Okay, if you want to see that the formulas, everything, children, you can go to the my previous video. And if anyone has not subscribed my channel, please subscribe it. You will be getting the notification from me. Okay, when I am going to take the class, everything will be scheduled. So please subscribe my channel. So here A is equal to 306 and B is equal to 656. We have to find out the LCM. Okay, right? So what is the formula actually? We know that HCF into LCM is equal to A into B. Okay, this is the formula actually. What do you want to find out? LCM. So LCM is equal to A into B upon HCF. Okay, A into B upon HCF. So this is the formula, right? Now what is A? A is equal to 306. 306 into what is B? 657. 657. And what is HCF? HCF is equal to 9. HCF is equal to 9. Okay, HCF is equal to 9. Now, do you want to multiply this or do you want to cancel this? What you will do? Do you want to multiply? No need to multiply. Just we can cancel. See this 306, isn't it? What will be that 9 4s are? What is the number here? 9 and 306. 9 4s are 36. 9 3s are 27. Right? 27. Right? Sorry. 9 3s are 27. Wait. Yes. Here what we are written? 306. 306. That is 9 goes on 30. 9 3s are 27. And 27 plus 3 is equal to 30. So this 3 we can write here. 3 we can write here. 9 goes on 36 4 times, right? So 34 into 657. Multiply this. Okay. 34 into 656, that is equal to 22,000. Yes, correct, Persia. Yeah. Persia is very active. That is 22. Very good. 22,338. Correct. Okay. Multiply these two numbers, 34 and 657. If anyone has not got this number, please multiply 657 into 34. You will get 22,338. So LCM is equal to 22,330. Very important question. Always this type of question will be there. Okay, because sometimes you want to find out HCF. Sometimes you want to find out LCM. Sometimes you want to find out A and B also. That type of question is not in your textbook, but I'll give you afterwards. Okay, what are A and B? Those type of questions are also there. What are the values of A and B? If HCF and LCM given, what are A and B? But it is not given in the textbook. Okay. So here, what is the one more time I'll explain that what do you want to do? HCF of given, inside the bracket of given, right? That means one number is A, another number is B. Okay, so don't get confused that what is A and what is B, because inside the bracket we are given 306 and 657. First number is A and second number is B. A and B we are given 306 and 657. That's all. And HCF of, that means HCF is 9. HCF is 9. Okay. So highest common factor is 9. We have to find out LCM. Use the formula. LCM is equal to A into B upon HCF. Okay. Then the 306 into 657 upon 9, that is equal to this one. Clear? Is it clear? Very important question. Okay. What is this next one? Is it the next one? 9 into 73, 657. What is this? I cannot understand. Next one. May I go to the next question? Yeah. Okay. Next question. May I go to the next question? Do one more time, children. Yes. I think next question, according to the textbook, I think it is different, right? Where is the next question? I cannot see where it has gone. Okay, now anyhow I'll take from the textbook. What is the next question? Check whether 6 raised to n, that is the next question. Check whether 6 raised to n can end with the digit 0. Okay. How many of you know that answer? 6 raised to n. Check whether 6 raised to n can end with the digit 0. Check. That is the question. Check whether 6 raised to n can end with the digit 0. And with the digit 0. With the digit 0. Okay, that is a question. I have taken that, but it is not seen now. Anyhow, I'll try it one more time. Check whether 6 raised to n can end with the digit 0. Now, see, you can check it one more time. You can check in the this one rough column. 6 raised to n, children. 6 raised to n. Okay, some children I know that when I'm teaching, some children can't understand this concept really well. Okay, but I'll start from the basic. What is actually? What does it mean? Okay, what is that meaning of the question? 6 raised to n. If you are substituting 1, you see 6 raised to the power. N means n can be, what is the natural numbers? 1, 2, 3, 4, 5, 6 and so on. Okay. So 6 raised to n, if you are substituting any value for n, 6 raised to 1 is equal to 6. 6 raised to 2 is equal to 36. Right? 6 raised to the power 3 is equal to 216. Okay. So same way 6 raised to the power 4 is also ending with the 6. You can check it. All the numbers will be ending with the 6. You see, 6. 6 raised to the power 1 is equal to 6, 6 raised to the power 2 is equal to 36, 6 raised to the power 3 is equal to 216 and so on. Now see, can you see any digit as 0 here, ending digit, unit digit as 0 here? No, we cannot see. Why it is, why we are not getting 0? That is a question. Why? What is the logic behind this? Why we are not getting 0? Can you say that why we are not getting 0? Any number is ending with a 0. You see this. Suppose I am not writing the answer is different. I am explaining. Okay, the question I am explaining. Suppose children, you just 10. What are the factors of 10? 2 into 5, right? 2 and 5 are the factors, right? Ending with a 0. Am I right? Ending with a 0. So 2 and 5 are the factors, right? Now another one I'll take, digit ending with a 0. 100 will take. Okay, otherwise 20 will take. 20, simple number. 20 will take. This 20 is ending with a 0, no doubt at all, right? 20 is ending with a 0. What are the factors of 20? You see, factors of 20. 2, then 10, 10 2s are 20, 2, 5. See, 20 is equal to 2 square into 5. Can you see any number other than this 2 and 5? Again you take, that is 2 and 5 must be there, right? 5 must be there. You see this. Again you take 30. 30. I am taking, because all these numbers are ending with 0. You see, 0, 0, right? Now you take 30, children. 30. This also will see the factorization. 2, right? 2 15s are 30, right? Then 3 5s are 15. Am I right? So 30 here we can write 2 into 3 into 5. Can you see 2 and 5 here? Can you see 2 and 5? Here can you see 2 and 5? Can you see 2 and 5 here? Okay. Any number you take ending with a 0. You take, suppose you take 50. I'll do 40, I am leaving. 50. Okay. What are the factors of 50? 50. Then 2, 25. Then 5, 5. You see the factors 2 into 5 square. 2 into 5 square. You see, are you getting 2 and 5 here? Yeah, 2 and 5, right? So actually the theorem behind this type of questions are, when any number is ending with a 0, children, any number is ending with a 0, their factors you can see 2 and 5. Okay, factors will be in the form of 2 and 5. 2 and 5 will be there as factors. It can be other number, but there will be a factor like 2 and 5. Then only that number is ending with a 0. Okay, now 6 raised to n. Okay, original, I am going to the question. First I was explaining. You have to understand that when the numbers are ending with a 0, what are the factors? 2 and 5. Okay, now we are taking the original question. What they asked? 6 raised to the power n. Okay, 6 raised to the power 6. We are given a 6. Okay, 6 is not a prime number, right? 6. Now 6. What are the factors of 6? 2 and 3. Am I right? 2 and 3. Now this we can write as 2 into 3 whole raised to the power n. Am I right? But here you see, this you can see when any number is ending with a 0, 5 we can see. Any number is ending with 0, 2 and 5 we can see. Here 0, then ending number is 5. Here again 0, ending number is 5. Isn't it? Not an ending number is 0, then factors are 5, 5, 5. Okay. Can you see any 5 here? Can you see any 5? No. Okay. So when we are factorizing 6, we are getting only 2 and 3. We are not getting in the form of 2 into 5. Am I right? 2 into 5. That's why the 6 raised to the power n is not ending with the 0. Do you understand? Suppose the question is, if they are asking 10 raised to the power n, always ending with the 0. No doubt at all. Because 10 is 2 into 5. Original format of the number which is ending with the 0 is always in the form of 2 into 5 form. Got it? So 2 into 3 whole raised to the power n. Therefore, what we can write, since it is not in the form of, since the factors are not in the form of 2 into 5, or since this is not in the form, this is not, I cannot write properly, this is not in the form of, 2 into 5 raised to the power n. This number is not 2 into 5 raised to the power n. 6 raised to the power, what is the question? 6 raised to the power cannot end with the digit 0. Cannot end with the digit 0. Did you understand? End with the digit 0. End with the digit 0. End with the digit 0. Okay? End with the digit. This one, no, I cannot write. I have to just little bit thicken the nib. Let me see. Yes, I'll take this. That's right. Do you understand? Okay? Or did you understand this? Why it is like this? 6 raised to n. First you want to factorize 2 into 3 whole raised to the power n. Here explanation, I was explaining the concept. Do you understand? Here I was, this is why. Hey children, this one I cannot see. Yes, this one. Yes. Okay. So first what you want to do? Tell me. First, any number. Repeating question, it has repeated many times. Not only 6, many numbers will ask. Sometimes 8. Can you say that 8? If 8, can you explain that why 8 raised to n cannot be ending with 0? Can you see 5 there as factor? No. You cannot see any 5 in 8, right? So this way, what you can do is any number you can prove like that. Suppose the question is 8 raised to the power n, children. 8 raised to the power n. Okay? Suppose the question is why 8 raised to the power n is not ending with 0. 8 raised to the power n. Now tell me, that is 8. What are the factors of 8? 2. 2 4s are 8. 2 and 2, right? So 8 is equal to actually 2 cube. Can you see any 5 here? 2 cube. So that's why we can take any number like this. Okay, many questions are there. You practice it. 6. Did you understand? Did you understand? So only 2 lines, but you want to understand that. You want to factorize that 6 raised to n. Okay, I'm not getting confusing this one. Leave it. You study only this one. Now first time you are studying this lesson. If you are revising, you take more questions. When you are revising, you take more questions. Now this is the concept. Do you understand? Factorize this, then write that this is not in the form of 2 into 5. Okay, did you understand? May I go to the next? What is the next question? Next question is what is that? There is a 7th question, right? There is a circular path around a sports field. Sonia takes 18 minutes to drive one round of the field. While driving, wait, I'll take the question. Yes, here, yes. Next one is 6th question is different, right? Explain why 7 into 11 into 13 plus 13 and 7 into 6 into 5 into 4, yeah, are composite numbers. Why they are composite numbers? Why they are composite numbers? That is a very easy question. 7 into 11 into 13 plus 13. And why it is a composite number? Because here we can take 7 into 11 into 13. 13 is the common factor, right? 13 is the common factor. Yeah, Jagat Prakash, good evening. 7 into 11 into 13 plus 13. So 13 is the common. The 13 you take outside. 13 you take outside. So inside the bracket you will get 7 into 11 plus, if you have taken 13 outside, here 1. Okay? Here that means 7 into 11 into 13. That means from this we can take 13. 113 is there. In second term also we have one more 13, right? So what is the common factor? 13 is the common factor. That 13 you take outside. Inside the bracket you will get, when you have taken 13 outside, 13 gone out. So inside the bracket you will get 7 and 11. So inside the bracket 7 into 11. Okay, and here 13 again taken outside, so 1, that is equal to 13 into, what will get? 7 into 11 is 77 plus 1 is equal to 13 into 78, right? 78, that means there are more than 2 factors. Yeah, more than 2 factors. Actually prime number means you will get only 13 into 1, like that only, right? But here 13 into 78 into, actually it means 13 into 78 into 1. There are more than 2 factors we are getting. That's why it is a composite number. Right? That's why it's a composite number. Because here common factor will be there. That common factor take outside. Okay. Hi. I don't know, Soumya. Okay. Hi. Hi, Soumya. Okay, I'm very glad to see you all. Okay, children, this is very easy question. 7 into 11 into 13 plus 13. Here 13 is the common factor. 13 is the common factor. The 13 take outside. Inside the bracket you will get, this way you want to show that simply you cannot write one word. There are 2 factors. How we are getting 2 factors? Okay, write down there. Take the common factor outside. 13 into 77 plus 1. 7 into 11 is 77. 77 plus 1, 78. So 13 into 78 into 1. So you can write, since there are more than 2 factors, the number is, that is the 7 into 11 into 13 plus 13 is a composite number. Okay? It's a composite number. You have to write the reason also. Write the reason also. There are more than 2 factors. There are more than 2 factors. There are more than 2 factors. More than 2 factors. More than 2 factors. Therefore, it is a composite number. Okay? Therefore, it is a composite number. This way you have to write the reason, otherwise you won't get mark. Do you understand? Otherwise you won't get mark. Okay, that's why it's a composite number. Now what is the 7th question? 7th one. What is the 7th question? Tell me. 7th one. Do you know that here in this chapter I have told you, here the main concepts are actually LCM and HCF, children. LCM and HCF. Okay. So here always repeating question, I'll tell you. The repeating questions are, always the repeating questions are, one question is root 2 is irrational, we want to prove, root 3 irrational, we want to prove, root 5 irrational. Likewise, one question will be there. Then next one is a word problem like this. Okay, a word problem like this. There is, see this question. There is a circular path around a sports field. Sonia takes 18 minutes to drive one round of the field, while Ravi takes 12 minutes for the same. Suppose they both start at the same point at the same time and go in the same direction. After how many minutes will they meet again at the starting point? Okay, that means after how many minutes they will meet again. That is the question here. How many minutes, after how many minutes it will, what is that? After how many minutes it will, they will meet again. Okay. Now see this, one circular path is there. So always in this chapter we can say that either you want to find out the LCM. Okay. Either you want to find out the LCM or you want to find out wait. Okay. Either you want to find out the LCM or you want to find out the HCF. Always this will be the question from this. If you are getting a word problem like this. Okay. And one more thing, children. If anywhere they are asking maximum. Okay. Somewhere they are asking what is the maximum time taken. What is the maximum distance they traveled. What is the maximum kilometer they travel, something like that. Maximum is there. You have to find out the HCF. Okay. There the question will be, you want to find out the HCF. Okay. HCF. But in the case of minimum, what is the minimum distance travel? What is the minimum time taken? Then minimum amount of money they have to give. Likewise, minimum anywhere they asked, you want to find out the LCM. Do you understand the difference between the HCF and LCM? Whenever they are asking maximum, you want to find out HCF. Whenever they are asking minimum, you want to find out the LCM. That is the tactic behind this. That is a shortcut. Now you can see that in this question itself, one circular path is there and 18 minutes and 20 minutes. Here Sonia takes 18 minutes. One girl is actually there. She's rotating the circular path 18 minutes. One girl is at 18 minutes. Another boy, that is Ravi, takes 12 minutes for the same. So what happens? Ravi actually runs fast, right? Within 12 minutes he reaches the destination point. 12 minutes. Right? But Sonia takes 18 minutes. Then can they meet at the which one, at 12 minutes? Minimum or maximum you want to find out here. You have to take the LCM of 12 and 18. You got it? You have to find out the LCM, because LCM will be bigger than 12 and 18, right? LCM will be the bigger than 12 and 18. So you want to find out the LCM of 12 and 18. So what will be the LCM of 12 and 18? Can you see the board? Can you see the board? I don't know. Anyone please give me in the chat box. So LCM of 12 and 18. What will be the LCM of 12 and 18? LCM of 12 and 18. Okay, LCM of 12. So you can write 12 and 18. Then again 2. 2 goes on 12 6 times. 2 goes on 18 9 times. Right? So 6 and 9. The common factor is 6 and 9. 3. 3. 3 goes on 6 2 times. And 3 goes on 9 3 times. Okay, 3 goes on 9. So what is the HCF here? HCF is 6. HCF is 6. But what is the LCM? LCM is equal to 2 into 3 into 2 into 3. Okay, multiply the common factor and the numbers which are not common. This also you want to multiply. 2 into 3 into 2 into 3, that is equal to 6 into 6 is equal to 36. Okay, is equal to 36. That means what is that actually what is the answer? 36 means they will meet after 36 minutes. Okay, Sonia and who is the another name? Ravi. Sonia and Ravi will meet after 36. Sonia and Ravi will meet after 36 how much 36 seconds or minutes, what they are given? 36 minutes. Okay, 36 minutes. Do you understand? 36 minutes. If you are taking the HCF of 12 and 18, HCF of 12, and you just think about the logic behind this. One circular path is there, one is rotate, one is reaching the destination by 12 minutes. Another one is reaching the same destination by 18 minutes. One is 12, that means Ravi reaches by 12 and Sonia reaches by 18 minutes. Okay, this is Sonia. Sonia reaches by 18 minutes. So, will they meet at the HCF? What will be the HCF of 12 and 18? Can you say? 6. Okay, will they meet at 6 minutes? No, it's not at all possible, right? Even Ravi takes 12 minutes. So, how they will meet at 6 minutes? So, should not find HCF. Children will be making mistakes there. They will find sometimes, they will find HCF. But HCF will be the actually lowest number. Am I right? HCF common factor 6. So, they never meet at 6 minutes. That you want to understand. Okay, what is the logic behind this? They will not meet at 6 minutes because 6 minutes, they are during 6 minutes, what they are doing? They are running, right? They are running. 12 minutes only that Ravi reaches there, that destination, right? So, always you want to find out the LCM. Don't forget it. LCM of 12 and 18. That means after 36 minutes, they will meet again. Okay, so one more important point you want to remember here. Whenever they are asking maximum time, you want to find out HCF. Okay, when they are asking minimum, wherever it is minimum any question is there, you want to find LCM. That's all. But here no such word we are given. LCM or HCF is not, maximum or minimum not given, but you have to understand the logic behind this. Okay, both are running. So if they are running, so what will be the LCM only? HCF, when you are taking HCF, they will not meet 6. HCF of 12 and 18 is 6. Okay, after 6 minutes they will not meet, right? They will not meet each other. So it will be greater than 12 and 18. That's you want to understand that. More than 12 and 18. So that will be more than 12 and 18, always the least common multiple, not the factor. Common multiple, that is 36. Clear? Take more sums like this and do it, children. Okay? Yes. Now, okay. Now, what is the next question? Yeah, LCM is equal to 36. Correct. 36. Correct. So, after 36 minutes, they will meet each other. Right? Do you understand? After 36 minutes, they will meet each other. That is the answer. Okay. Now I have taken the question. That's what I am thinking. Okay, now this question is actually, yes, it's coming. Yes, prove that, I think first question is actually, next one is, prove that root 5 is irrational, right? Prove that root 5 is irrational. That is the question, right? Yeah, this is the question. Prove that root 5 is irrational. Okay, this is the question, right? Exercise question number 1. 1.33 theorem. Which one? Yeah, theorem. Yeah, root 5 is irrational. That's what I have taken. Root 5 is irrational. Okay, prove that root 5 is irrational. Any doubt? This is what I am going to take. Now, this one, children, you have to study. I told you, this is actually important. So, how to prove that root 5 is irrational? Just listen carefully. Then, if you are studying this first time, many are there studying first time. Many have completed. I know that someone might have completed, but many children will be there which are new. So, root 5 is irrational. So, what is actually irrational number and what is the difference between the rational number and irrational number? Can you say difference between the rational number and irrational number? Rational number can be expressed, that is as the P by Q form, right? All rational number can be expressed as P by Q form, where P and Q are integers and Q not equal to 0. That is the real definition of the rational number. Every number can be written as a P by Q form, right? But if it is irrational, we cannot write as a P by Q form. Am I right? So, if you want to prove root 5 is irrational, actually this proof we are proving by the contradiction method. That method is known as contradiction method. Okay. So, in your textbook, we are not learned, only in the 10th standard we are studying this method. Contradiction method we are taking and proving that it is irrational. Okay. The method says that, what is this method actually? First we will assume that it is rational. Okay. First we will assume that it is rational. Root 5 is rational. So if root 5 is rational, we can write that root 5 can be written as A by B form, where A and B, that is P by Q form. Normally we are using P by Q form, where P and Q are irrational number and Q not equal to 0. Isn't it? So same way I have to start. Okay, proof. Just say this proof. Okay. So first, contradiction method, I told you, this method we are studying by the contradiction method. So first let us assume that root 5 is rational. Root 5 is rational. What we have to prove here, it is irrational, right? But we have to assume that root 5 is rational. Okay, rational number. Root 5 is rational. First that means just opposite of irrational number. Opposite of irrational number is rational, right? So first we are assuming that root 5 is rational. So you know that if root 5 is rational, any rational number can be expressed as P by Q form. right? So root 5 is equal to a by b. So root 5 is equal to a by b, where a and b are co-prime numbers. Where a and b are co-prime numbers. Do you know why we are saying it's important? A and b are co-prime numbers. A and b are co-prime numbers. You have to write this, otherwise you will not get mark. Half mark must be deducted from this whole theorem. Actually, this is 3-mark question. Always it is repeating 3-mark question. They will not give for 2 marks or 4 marks. It will be a 3-mark question. And wherever, what are the step mark here? First they will write that root 5, that is here if some children are not written this co-prime, they will deduct half mark from this. Okay, a and b are co-prime numbers and b not equal to 0 and b not equal to 0. Okay, b not equal to 0. Rational, isn't it? And b not equal to a and b are co-prime numbers. Do you understand? What is the meaning of co-prime numbers? I'll tell you. No prime, that is no common factors are there. Co-prime numbers means no common factors are there. A and b are like 2 by 3. They are co-prime numbers. 2 and 3, no common factors are there other than 1. Right? Then 3 by 5, no common factors are there other than 1. Am I right? So first we are assuming that they are co-prime numbers. Okay, that's what I'll rub this and take this again. So a and b are co-prime numbers. So next one, so this is important, always I am telling this is important. The mark, step mark will be like this. I don't not write it, but I am telling half mark for this step. Okay, now cross multiplying this one. Cross multiplying, that is root 5b is equal to a. Just cross multiplying. B will go to this side and root 5b is equal to a. Just cross multiply. And next one is squaring on both sides. Squaring on both sides. Squaring on both sides. Squaring on both sides. That means root 5b whole square. Root 5b whole square is equal to a square. Both sides we are squaring. Okay. Now, after that, root 5b whole square is equal to a square. A and b and not equal to 0. Yeah, b not equal to 0. B, that's why I have written here b not equal to 0. And b is not equal to 0. Write is simple, no problem. Is not equal to, we can, no need to write in words, b not equal to 0. So root 5b whole square is equal to a square. Right, children? After that, what is root 5b whole square? 5b square. Root 5 whole square is 5. So 5b square is equal to a square. Okay? 5b square is equal to, root 5 square is 5. 5b square is equal to a square. Therefore, b square is equal to a square upon 5. Am I right? A square by 5. Right, children? B square. 5 will come down, so a square by 5. That means you see the left hand side. Sorry, not left hand side. Right hand side. Right hand side is a square divides 5. Okay. So, here we can say that 5 a square divides 5. So, 5 is divisible by a square. That means a square, what is that? What we want to write? A square, a is divisible, right? Isn't it? A square is divisible by 5. Am I right? Divisible by 5. So, if a square is divisible by 5, we can write that a is also divisible by 5. Okay? You see that a is also divisible by 5. We'll see this. Suppose any number, 25. 25 is actually, we can see that 25 is divisible with the 5, right? 25 is in the table of 5. So, it is divisible by 5. So, you take the square root. What is the square root of 25? 5. 5 is also divisible by 5. That is the meaning. If a square is divisible by 5, a is also divisible by 5. A is also divisible by 5. I don't know why I cannot write with this pen tab today. My writing is also really ugly, right children? See, divisible, A is also divisible by 5. Okay, this is the concept. If A square is divisible by 5, A is also divisible by 5. Okay, I'll take another example. You take 89. You take 9. 9 is divisible by 3. Any doubt is the 9 you can see in the table of 3, right? But you take the square root. What is the square root of 9? 3. So that 3 is also divisible by 3. So any number A square is divisible by 5 means that square root is also divisible by 5. Okay. Now if A is divisible by 5, you see that A is divisible by 5. That means what is the meaning of A is divisible by 5? I'll tell you. Little bit, if you are understanding this concept, you can write easily. No need to mug up. Okay, no need to study as by heart. That means like what we are, how we are studying the social history, geography and all. Like this, we are sometimes we will be studying by heart, right? All the names and all. So that way, most of the children are doing like that. They are by heartly they are learning this one. But no need if you are understanding the concept. So A is divisible by 5. So if A is divisible by 5, you see that A can be written as 5 into another number. A is divisible by 5. You know that what is the meaning of A is divisible by 5? Any number, 25, it can be 25 children. It can be 50. Okay, divisible by 5. Multiple of 5. 5 5s are 25. 5 10s are. Any number which is the divisible by, which is a multiple of 5. That is the meaning. A is also divisible by 5 means you can write A as 5 into another number. 5c. Okay, you see this 25. 25 you can write as 5 into 5. Right? Suppose this is C. 5c. 50. How you can write 50? 50 you can write as 5 into 10. Am I right? 5 into 10. That means 5. This is 5 and this is 5c. 5c. So any number which is divisible by 5 means that number can be written as 5 into another number. Okay. That's why A is equal to 5c we can take. Do you understand? Now this one you can name it as 1. Equation 1. Now this A is equal to 5c we are taken because A is divisible by 5. This one we can substitute in this number. Which one? In the equation 1. That is a 5b square is equal to A square we are written here. Right? First equation we are written here. 5b square is equal to A square. Where it is this here. I'll tell this one. Okay? Here. 5b square is equal to A square we are written here. The same A is equal to 5c we are written because A is also divisible by 5. Right? So same way what we can do is A is equal to 5c. This 5c substitute in this equation. Okay. So 5b square is equal to A square. So 5b square is equal to what is A now? What is A now? A is equal to 5c. So 5c whole square. Got it? Because A is divisible by 5. So value of A is equal to 5c. Now A square is equal to 5c whole square. So 5b square is equal to 25c square. 25. 5c whole square is 25c square. Therefore, b square is equal to, tell me, b square. 5b square is equal to 25c square. Therefore, b square is equal to 25c square upon 5. 25c square upon 5. Now, 5 and 25 get cancelled. 5c square. That means b square is equal to 5c square. Do you understand? B square is equal to 5c square. That means b square is the multiple of 5. Okay? B square is a multiple of 5. That is b square is divisible by 5. You got it? Now here we have proved that what we have proved here we have proved that A square is divisible by 5. Now here we are getting b square is equal to 5c square by, that is b square is equal to 5c square. Now see, b square is the multiple of 5. Some number which is a multiple of 5. That means b square is multiple of 5. Okay, see carefully, it is little bit difficult, I know that, but study like that. B square is equal to 5c square. That means b square is divisible by 5. Is divisible by 5. Okay, is divisible by 5. If b square is divisible by 5, children, we can say that what same way I have told you here. If 25 is divisible by 5, we can say that 5 is also divisible by 5. Right? So same way, if b square is divisible by 5, we can say that b is also divisible by 5. B is also, because we have a theorem there. The theorem is in the textbook. It is actually, it is one theorem is there. If square is divisible by 5, square root is also divisible by 5. No need to write the theorem here. You can write this. Okay. So just you can write the next step. If b square is divisible by 5, b is also divisible by 5. Divisible by 5. Do you understand? So what we are taken in the right from the beginning, we are taken that root 5 is equal to a by b, where a and b are co-prime numbers. See this. We are seeing that it is co-prime numbers because no common factors are there. We are assumed that, let us assume that it is a rational number and root 5 is equal to a by b, where a and b are co-prime numbers. Rational, we are taken rational and we are taken it is a by b, and a and b are co-prime numbers. That means no common factors are there. That is our assumption. Right? That is our assumption. But what we have proved now, after taking that, we have proved that a is divisible by 5. Okay, that is a by b, numerator is divisible by 5. Okay, now last one, see, b is also divisible by 5. See, b, that is denominator is also divisible by 5. That is both numerator and denominators are divisible by 5. Can you understand something from there? A by b. A is divisible by 5. B is also divisible by 5. That's what we have proved now. A is divisible by 5. B is also divisible by 5. But what we are assumed? We assume that there are no common factor, co-prime numbers. Okay? But according to that, we have to get no common factors. But what we got here? We are getting 5 as a common factor. Can you understand? 5 is a common factor. So there we are getting a contradiction, right? 5 is a common factor, right? So there we are getting a common factor. Therefore, what we can say, 5 is a common factor. 5 is a common factor for, what we can say, 5 is a common factor for both A and B. Both A and B. Do you understand? Both A and B. Now that's what we have proved now. Okay. A is divisible by 5. B is also divisible by 5. But it is actually, it should not be like that. No divisible number should be there according to our assumption. Can you understand? Our assumption is A by B. It's a rational number and it has no common factor. Okay. Rational number, no common factors are there. That's why. But here there is a common factor. 5 is a common factor. So 5 is a common factor for both A and B. So there, what is that? There arises a contradiction. So there is a contradiction that what we can write. So the contradiction, there is a contradiction that there is a contradiction. There arises a contradiction that, what is the contradiction? There is a contradiction that the fact, what is that? Contradicts, sorry. It is a contradicts the fact that there arises a contradiction, or there is a contradiction. Okay, or write the same sentence. In textbook it is given there. It is write the what we can say that this contradicts the fact that in the textbook I think it is given like that this contradicts the fact that this contradicts the fact this contradicts the fact that A and B have no common factor. A and B have no common factor. No common factor other than 1. No common factor other than 1. Okay? Other than 1. This contradicts the fact that A and B have no common factor other than 1. That is the contradiction we have proved. Okay, we assumed, right? Other than 1. Therefore, what is the contradiction is actually, therefore, our assumption is wrong. Therefore, our assumption is wrong. What is our assumption? Therefore, our assumption is wrong. Therefore, our assumption is wrong. What is our assumption? Assumption was, what is assumption? Root 5 is rational. Okay, that is wrong now. The assumption is wrong. Root 5 is irrational. Root 5 is irrational. Okay, this way you have to write this proof. Do you understand? So, one question must be there like this, root 2, root 3, root 5, root 7, etc. Okay, this type of question will be there. Got it? So, many children will be having problem regarding this theorem. Okay, so 50% children will be writing, but remaining 50% can't understand and they'll mug up the theorem. Whatever it is, I'll learn it that way. But no need, just understand and write. First we have to write that root 5 is equal to A by B, our assumption. Root 5 is equal to A by B, A and B are co-prime numbers. Then root for cross multiplication, then root 5B is equal to A. Then squaring on both sides, square. When we are squaring on both sides, root 5B whole square is equal to A square. Both sides we want to make square. Okay. Root 5B square, that is 5B square is equal to A square. So B square is equal to, take the 5 down, A square by 5. So A square, that means A square divisible by 5. So A square is divisible by 5, A is also divisible by 5. If A is divisible by 5, you name it as A is equal to 5C, 5 any other number. Okay, other than A and B, take C, D, Q, anything. So I have taken here C, A is equal to 5C. Now 5B square is equal to A square, substitute in that 5B square A square, 5B square is equal to 5C whole square. So 5B square is equal to 5C whole square, that is 5 square is 25C square. So B square is equal to 25C square by 5, 5 cancel, we can cancel, that is 5 and 25 can be cancelled, 5, that is 5C square. Okay. So, B square is equal to 5C square, that means B square is equal to 5C square means B square is the multiple of 5, that means it is divisible by 5. Okay, B square is divisible by 5, so B is also divisible by 5, so 5 is a common factor for both A and B. Okay, both A and B, A also 5 as a factor and B also 5 as a factor, right? So, both A and B, therefore, our assumption, this contradicts the fact that A and B have no common factor other than 1. Therefore, our assumption is wrong. Root 5 is irrational. You got it? Same way you want to study other same method is given in the textbook. Same format only. Textbook, in that theorem it is given in the textbook. I think it is root 2 given, right? Root 2, root 3, everything. Root 2 is given there. So, learn that same format you want to study. Okay, so I am going to wind up. I told you till 8 o'clock. So I am going to wind up. Next class I will be coming with other questions and important board questions. Okay, these 3 questions and the important board questions in the next class. Okay. Now I know that all the people, sometimes some children will be having holidays. I know that some will be having classes. So you have to. Sometimes the homework will be there, so I am just wind up now. Okay. So next class we will see Bye then. Bye children. Okay, bye to all. Bye. Irrational cannot be expressed in P by Q form. Never. Only rational can be expressed in P by Q form. Only rational. That's why we are assumed as rational. Okay, that's why we are assumed as rational. Any other doubt in this? Clear your doubts if you have. Any other doubt, children? Any other doubt is there? Okay, here this 1.3 theorem. Okay. B is an article. That is okay. So, Pro 3. Next class, I will be coming with a repeated board questions. What are the questions in this chapter? Repeated questions. Okay. We'll see that. Some questions we are not given in the textbook, and others I will be taking some from R.D. Sharma and other competitive books. Okay. And I will be taking that. Okay. Bye, children. Bye. Bye.